So let's say we have the fraction 5/6, and we want to find two fractions that add up to that. So obviously that would be easy, because you could do 1/6 and 4/6, or you could do 3/6 and 2/6, or something like that. The ones we're doing today aren't that easy because they've got variable stuff in them too. So just stick with me here. We can factor down 6 into 2 times 3, right? So this fraction could be something over 3 plus something over 2. Isn't that true? That we could get the fraction 5/6 by adding something that's thirds and adding something that's halves. And where did I get that? Well, 6 factored is 3 and 2. And the way you get a common denominator is by multiplying what it's missing. So like this one, if you multiply by 2 over 2, you get your 6 denominator. And this one, if you multiply by 3 over 3, you get your 6 denominator, right? So what we're going to be accomplishing today is figuring out what those numbers will be. And the way we're going to do that is multiply the whole thing by 6. So when we do that, 6's here will cancel out. And we multiply by 6 here, and we get 6, 3 goes into 6 twice. So this 5 is left over. If the 3 went into the 6 twice, we have the x left. And then the 6 will go into, the 2 will go into the 6. So we have 3. So we know that whatever x and y are, 5 equals 2x plus 3y, right? So that's an equation, like in our system of equations, isn't it? So we would need another equation to figure this out. We would need something else. And so sadly, because this problem is so simple, I'm like not even sure what to do with this at this point, because I just made this up on my head. And I'm like, how would we figure it out from there, other than the obvious that x and y are probably both 1, because 1 times 2 plus 1 times 3 adds up to 5. So if I find those values, then I know my answer is that 5/6 is the sum of 1/3 and 1/2, because 1 times 2 plus 1 times 3 adds up to 5. So anyway, that's in a nutshell what we're accomplishing today.
Okay.
Okay. All right. So we have all these rules based on what types of factors we have. We need to always make sure we factor. Where is that? For the proper rational expression with Q factored into distinct, irreducible factors. That's always your first step. The problem is given to you in factor form, you're good. If it's not, you have to factor the denominator, not the numerator, just the denominator. And you're going to break up your fraction based on the factors in the denominator. Okay? And then we're going to, my favorite thing to do when we can use it is a thing called the convenient x method. You're going to see that in just a minute. So this kind of just explains the steps that I'm going to be going through. So then maybe after you've seen some of these examples, you can go back and look at those steps and see how they apply. And we are actually going to go back and look at these too. So non-repeated linear factors. If all of our denominator factors are linear and none of them repeat, we use this one. If they repeat, we use this one. And I know right now they're just kind of a bunch of hodgepodge. So, and then if you have quadratic factors, there's a whole other rule to follow. So we'll come back and refer to these as we do these examples. Okay, let's go to example 1. And just like jump into this so we can try to understand what's happening. So, is our denominator factor? That's our first step. Our denominator is factored, correct? You know what I mean by the denominator is factored? Yeah, denominator is factored. Yeah? What kind of factors are they? Are they linear or quadratic? What's the powers? Do they have powers? No, x plus 1 is a linear factor. X plus 2 is a linear factor. X minus 2. because they don't have squares on them. They're not irreducible quadratic factors. We learned about those in chapter 2. Okay, so we have it factored completely into linear factors. So that means we are going to look at this first type of problem right here. We are just going to use some variables. For some reason, when we do this process, we use these capital letters, not to be confused with matrices. We're just using them as variables. So we're going to put a variable a over a fraction with our first factor, and then a variable b over our fraction with our second factor, and we would keep doing that for each linear factor. So that's going to look like this. So I'm going to rewrite this. So I have that on one side. X plus 1 times x minus 2 equals a over x plus 1 plus b over x minus 2. Okay, so it's factored, and then I've set up my problem with each individual factor being a denominator of a separate fraction, with a variable on top because I don't know those numbers yet. Okay, the next step we are going to do is we're going to multiply everything through by the least common denominator. So we're going to multiply least common denominator, which is x plus 1 times x plus 2. I like to write it down when I'm showing my work. I write it down everywhere so I don't forget it, and I cancel stuff out. So that's a times x plus 1 times x plus 2, and b times x plus 1. Should I change my x minus? It should be an x minus 2. So you're probably thinking, is that supposed to be a minus 2? Should I tell her she's doing it wrong? We're going to get all the way to the problem and have the wrong answer because she wrote plus instead of minus. How many times does that happen, Michelle? Too many. Okay. So now we're multiplying by that over 1 on each problem. And that allows us to reduce out the denominators. So for your first fraction, the least common denominator should make everything cancel. If you don't completely get rid of your fractions, you've done something wrong. You haven't done the right least common denominator. So this one, our x minus 1 or x plus 1 cancels out. This one, our x minus 2 cancels out. What do we have left? So we should have 5x minus 1 left over here with no denominator because it canceled out when we multiplied the least common denominator. We should have a times x minus 2 because the x plus 1 canceled out. And then we should have b times x plus 1 because the x minus 2 canceled out. Our fractions are gone. We've gotten rid of those. We've just got these variables now solved, right? Okay, so one way to do this type of problem is to actually distribute the a through the parentheses and the b through the parentheses, and then line them up by type with our 5 and our negative 1. I like to use a different method called the convenient x method. Do you want me to show you both ways on this one problem? It might mean we get to fewer things in class, but you'll be able to see it both. I think saying 2 methods on one problem is sometimes helpful. And the reason I like you to have more than one method is 2 reasons. One is your preference, whichever one's easier for you. The other one is some problems you can do one way and some problems you can't. So, all right. I'm going to go ahead then and use kind of a more traditional way of doing this problem, which would be let's distribute. So I distributed through my variables. Now I'm going to gather like terms. So let me make kind of a note of what I'm doing. Distribute. Now we're going to gather like terms. Okay. So we don't know what A and B are. But we do know that this term AX and this term BX have to add up to find x. Because this side is equal to that side. So, if this side of our equation is equal to that side, and we can only combine like terms together, does it make sense that 5x has to equal ax plus bx? Because those are all like terms. We just don't know what the numbers are for a and b. Right? So those are our x terms. Now, what other types of terms do we have? We have our constant terms, don't we? So over here, our constant term is a -1, and the like terms we would add together over here to get that would be -2a and +b. Okay, now since these are all like terms, we don't know what x is, because this is x is generic for whatever x is going to be. We'll never know what x is, and we don't care. That's not our job. What our job is to find a and b. So how about we ignore x? Sound like a plan? So if we ignore x, we have 5 equals a plus b, and we have -1 equals -2a plus b. Bam, I have a system of equations. Why is partial fraction decomposition in chapter 6? Because we have a system of equations that we can now solve using any of the methods we learned. So, we've spent a lot of time today talking about those methods. So I'm not sure that I want to go through that process right now. You could use substitution, you could use elimination, you could use matrices, you could do Euler's form or Cramer's rule, or inverse matrices. Whatever you really want to do, you can do to solve that for a and b, and then you put it back together into your equation. Okay, so that is kind of the more traditional way of doing this problem. Let's look at the way that I like better, because then you don't really have to do this solving stuff at the end. So here's a different method. I'm going to call this the convenient x method. I think I spelled that wrong. And the convenient x method is where you choose a value for x. Maybe I didn't give you enough room for both methods. Okay, so what I'm going to do to use my other method is I'm going to go back to this step right here. 5x minus 1 equals a times x minus 2, the step before I distributed. All right, so set aside what we just learned, because you know how to take it from there and solve it, right? Clean slate. We just multiplied by the least common denominator. We just got rid of the fractions. Here we are. We haven't distributed yet because we're not going to. Okay, so here's our convenient x method. What happens to this problem if I let x equal 2? And why did I choose 2? I'm just choosing a random value for x, because x should represent anything. Right? So I'm choosing an x value. As long as I keep x the same throughout, I shouldn't be affecting anything with regards to the other values a and b that I'm trying. What happens if I let x equal 2? Why did I choose 2? See if anyone wants to answer that while I start writing this out. Why did I choose 2? I'm not sitting at my computer, so I can't see if anyone's contributing their answers over here or not. This video is getting far too long. What happens to the a value? Ah, this is 0. That means 5 times 2 is 10 minus 1, that's 9, equals 2 plus 1 is 3. 3b, what does b equal? that can be. I don't need to solve my system equations from the previous method because I have done that part. Okay, let's do A this time. I'm writing bigger than usual today. Okay, let's, what do you think? I'll let you guys guess what this one should be. Yes, let x equal -1. Perfect. So then we do 5 times -1 minus 1 equals A times -1 minus 2 plus B times -1 plus 1, which gives us -5 minus 1, -6, -3, and 0. So -6 divided by 3 means that A equals 2. Okay, you are not finished with this problem until you write the final answer. And the final answer is written by, just write it off to the side here, by taking what we did at the very beginning, right here, the red part, and putting the A and B where they belong. So A would be 2 over x plus 1, and B is 3 over x minus 2. We have found the partial fraction decomposition for this problem.